So for part 2 of the density lab, I have my spreadsheet set from when I started part 1. So now I'm going to do part 2 down here. And I need a column for the mass of my metal that I used plus the pycnometer that I had. So I have here 36.3, let's say, is my first trial. I put on the scale for the amount of metal I use. It changed each time. So I will just add in all the values that I have and type them in. And I need to make sure I keep my uncertainties on those things in there as well. So I'll put the uncertainty on the mass of the metal plus pycnometer. And the scale for all of those was 0.01. And I will just put that in. And put the cursor to the lower right corner and double click. And it fills it down and puts all in 0.01 for all of those. I know what's coming up ahead of time. So I'm just going to save myself the trouble and put in my percent uncertainty for this as well. So I'll put that in, and it's mass plus metal, metal plus pycnometer, and I want the percentage of that. I'm going to resize this column. You can see the percent sticks out, so I'll just move my cursor up to the middle here and double click, and it'll resize it automatically. This is going to equal my absolute uncertainty divided by the actual value there. I'm going to multiply it by 100 to make sure I get it into a percent. And I'll hit enter, and I'm just going to fill this down. The next part is what was the mass of the metal plus the pycnometer plus, remember I had to add water to fill this up. So this one here was just the pycnometer plus the metal that I put into it. And this one is now, what does it weigh after I fill up the stuff with water? And same deal, this is kind of too big for the column. So I'm going to resize that. And here's the values that I recorded or measured. 46, 44, 45.6, and finally 45.4. Again, I need to make sure that I have my uncertainties in here. Plus P plus W, and this is going to be an absolute. And again, that is also, for me, the scale that I used, it was 0.01, and likely the scale that you used as well. So I'll fill those down. Don't worry about this little dotted line here on the column that has appeared. This is just, if I was to print this, that's trying to show me the print view. So like this stuff here would all be on the first page, and then everything on this side would be on the second page if I printed it off the way it's set right now. I also know what's coming up on this, so I'm just going to, I think I'm going to get my percentage uncertainties as well on this. And we will resize the column, and that's going to equal this, divided by the actual value that's there times 100. And I will make sure to fill that down. There we go. Okay, so now I need to do some calculations, and I want to know what, let's see, when I had the water in there, how much of this was just water? And so what this is going to be is that's going to equal the mass of all of these things, the metal, the pycnometer, and the water, and I have to subtract off the mass of the metal and plus the pycnometer. So I will do that and fill down for each one, figure out how much mass in grams of water I have here. And I want to know what is the absolute uncertainty on that. And that is going to be, what did I do? I took this value here, here's its absolute uncertainty, and I subtracted from this value this value. When we subtract, don't forget we add the absolute uncertainty. So I'll take this uncertainty, I'll add it to that one. And it ends up being nice 0.02 for each one of them. Now, I'm going to skip for the percentage right now. I maybe got a little carried away on these. I'm not sure if I need these percents, but at least they're there if I need them. If I don't, I can ignore them. I'm going to wait on getting the percentage column until I actually need it here. So now I want to get the volume of water. How much volume of water did I actually do there? And to get the volume of water, I have to use the equation density equals mass per volume. And so how do I get volume? Volume is going to equal the density and I am going to divide it by, I'm sorry, it is not equal to the density, it is equal to the mass of water divided by the density. And here's my density of water. So I'm just going to pick one of those. I guess I'll just pick the last one for sake of argument. There it is. And there is my volume of water for that. And watch what happens when I fill down. I get some goofy stuff here that it doesn't like. And so let me show you what happened and how I can fix that. All right, so look what happened. So this one, if I click in here, sometimes it highlights the cells. And it says G13 divided by I4. Oops, my little labels are covering that up. So here's G13, this one right here, it's in blue. Shows you in blue, it's the blue one divided by the red one, which is good, that's what I wanted. But then when I move to this one and click inside here, it's now taking this mass, which is what I want, but now it's dividing by this cell. So when you do a fill down, yeah, it moved this one down, and I wanted to move that one down, but then it moved the density one down. And you can see, oops, you can see that when I go to the next one and click up here, to move the mass down like I wanted it to, but then it moved this one down. And I didn't want it to do that, and it did it for all of these. And so here's effectively what I want it to do. I want it, when I do the fill down, to move this one down during the fill down like normal, but I want this to be locked and kind of stay the same. I probably shouldn't use the word locking cell because that actually has a different meaning in a spreadsheet, but I want during the fill down for this to stay put. And so what I can do is once I have clicked this, I'm just going to retype this in again, okay? So it equals this cell divided by this cell. What I can do is one of two things. On a computer, I can press the F4 key, and that quickly puts in these dollar signs. It puts a dollar sign before the letter and a dollar sign before the number, and that means it's going to lock both that letter and that number during the fill down. And if I hit enter, it doesn't look like I changed anything here, but watch what happens when I fill it down again now. I actually get the numbers I'm looking for. So here, this one locked this one, and it moved the mass down like I wanted. If I look at this one, it moved the mass down like I wanted, but locked that number. And so that's a good way to make sure you lock cells during a fill down. If I didn't know about the F4, and you can simply, like say, okay, I want to do this number divided by that one, and it's not in there, I can move my cursor up to this top bar here. I can manually put in the dollar signs, and it will still work. So the F4 is just a quick way to do it fast, but you can also do it manually. All right, and that's the volume of the water, and I want to get the uncertainties on this. And so in order to do that, I'm going to put in d volume water percentage, because I use division to make this work. And I need, oops, looks like I did need the percentage uncertainty on that mass value, so I will move these over. Put in a d mass water percentage. That, oops, let's make that a percent. I want. Okay, this equals my absolute divided by the mass value times 100. And we'll fill it down. There's my percentages for each one. So for my water uncertainty percentage here, it's going to equal the percent uncertainty of this, because we did division. So when we're in percent uncertainties, it's the percent of this plus the percent of the density, which is 0. So effectively, I'm just doing this, and I'm going to fill those down. What did I do here? I want to redo. Hold on a second. Let me get it back. Okay, it looks like I just missed up on a fill down there. So now I got the volume of water percentage. So now what I want is the volume of the metal. And what's going on here, oops, let me move it over a little bit so we can see a little better. For some reason it cuts off my M on the screen, but it's really volume of M for metal. And then what I need to do would be to look at this pygnometer. The whole pygnometer has a volume of about 26 milliliters in my case. The volume of the water was 9. So I just need to subtract, take the total volume minus the water volume, and the rest has to be the metal. And so I need to take the total volume, but be careful because when I fill down, I don't want it to keep moving this one down. I'm going to lock it with F4, put the dollar signs in. I want to subtract the volume of the water. And I will fill that down accordingly to get the volume of my metal. Okay, I also need the uncertainty on the volume of the metal. And I use subtraction. So I have to, let's go d volume metal absolute. It has to be the absolute uncertainty of this plus the absolute uncertainty there. And so it looks like I need to move some columns over. Oops. And I need to actually have a D volume water absolute. And so this is going to equal my percentage divided by, okay, so it's this number, divide it by 100, and I'm going to times it by my actual volume of water. And so that'll give me my absolute uncertainty. I have that. All right, so again, since I did subtraction for these, my volume of, my absolute uncertainty on the volume of the metal is going to be equal to this one, which I need to lock, plus that one right there. And I will do a fill down for this. All right, so getting there. Okay, so now I've got the metal, the mass of the metal, or sorry, the volume of the metal. I need to get the mass of the metal. Now, here's the thing. You maybe have this recorded, and so it might look a little bit differently for you. I'm going to type in my mass of metal. This is actually something that I'm going to actually calculate. Now, you might actually type yours in. You maybe weighed these on the scale. But how I'm going to do mine, maybe I didn't weigh mine out ahead of time. I knew what the pycnometer mass was, and I added metals to it. So what this is going to equal is the pycnometer mass, and I'm going to subtract, sorry, the mass of the metal plus the pycnometer, and I'll subtract off this one. Not this one, where the heck is it? No. Sorry, the mass of the pycnometer. So in my case, it looks like I've got all the same masses here. If I had different masses of pycnometers, I'd maybe want to average them if it's supposed to be the same pycnometer. But I'll just pick this one, and I don't want that to change on a fill down. So I will go ahead and change that and fill it down. So there's my mass of metal I used each time. Now again, maybe you actually measure these directly before you put it in the pycnometer, so you would just type them in directly. And the D mass absolute, if you measured them directly, these for you are all going to be 0.01. But because I did subtraction on mine are going to be this uncertainty plus that one, since I used subtraction, and I need to lock that and fill it down. So I have all the stuff I need almost. I want to know what is my percentage on this. So let's do that. This number divided by that one times 100. And now finally I can get my density values for this metal. And the density value for the metal is going to be the mass of the metal divided by the volume of the metal right here. And I will fill it down, and there are all my numbers. It's probably easiest to quickly figure out the uncertainty percentage on the density of the metal, and so that is going to equal the percentage on my mass plus the uncertainty percentage on my volume, and I can fill that down, and I have all my values. Just quickly here, if I wanted to get this into absolute, I could do that. Okay, it would equal this number divided by 100 times the value that I get. And I can fill those down. And I don't get all the same number, but I get somewhere close. And so here are my densities of the metals. And again, if I want to know what's my average density, I can type in equals average, open parenthesis. I'll highlight all those densities and hit enter. And there's my average value for my density. Now keep in mind, if you do an average, you want to make sure the average actually makes sense. And in this case, yeah, an average looks pretty good. It's a good representation of what's going on here. You still might want to do an average regardless, but just keep in mind for your report, if your numbers are bouncing around, you might still want to get the average for some reason, but it's not necessarily a good representation of what you did. And that is LibreOffice for these calculations.